Welcome to Beyond Research, a podcast brought to you by Research Nova Scotia.
Coastal communities are increasingly having to better understand the marine environment, including balancing prosperous fisheries and endangered aquatic species.
It's estimated that more than 90% of large oceanic fish have disappeared since 1950s due to overexploitation, habitat destruction, and changing climate.
This is Dr. Sarah Iverson, Scientific Director of the Ocean Tracking Network, headquartered at Dalhousie University. Today, you'll hear how this Nova Scotia-based network has become the world's aquatic animal tracking network, deploying state-of-the-art ocean monitoring equipment around the world to inform conservation initiatives, policy development, and help monitor the health of the global ocean. Good afternoon, Sarah.
Good afternoon.
Nice to see you.
Nice to see you. It's good to be here.
Part of the interesting thing about this podcast series is we get to sit down and talk to researchers and scientists who are engaged in these fascinating things in Nova Scotia, where people wouldn't necessarily have thought that they would be here. But here we have an instance where Nova Scotia, this institute in Nova Scotia, is the global leader in this entire field. Can you tell me what the Ocean Tracking Network does?
Sure. The Ocean Tracking Network, or OTN, is a global aquatic research, technology, data management, and partnership platform that is aimed to transform the way that the ocean and its connected inland waters are viewed and understood, as well as the life that moves within them. As you have rightly said, aquatic animals are incredibly important to healthy ecosystems, which in turn provide immense economic and social benefits to mankind and to the world in which we live. But the world's aquatic animals are under ever-increasing pressure, and many aquatic animal populations in important fisheries are really in dire straits. For example, it's estimated that more than 90% of large oceanic fish have disappeared since 1950s due to overexploitation, habitat destruction, and changing climate. Many fisheries have collapsed off of our coast and certainly globally. And these anthropogenic impacts continue to alter populations. They alter habitats and habitat use, movements, migration, and survival, often in completely unknown ways. And they're unknown because trying to understand animals and their underwater world is just very challenging. And so OTN and OTN's technology and their partnerships are about opening this black box. So OTN's mission is to inform the sustainable use, conservation, and stewardship of aquatic animals by providing knowledge and turning it into policy and management change.
And so when you say you operate globally, how many countries and how many species? Give me a sense of how big this network is, how big this tracking network is.
Well, we currently have deployed about 2,000 OTN receivers, and I can explain what those are in a minute, globally. And we currently have, at last estimate, about 4,500 users and collaborators and partners from 40 different countries. And this is always ever growing and changing. And we are now tracking over 250 species, and our database has now reached some 625 million detection records.
So when you say 625 million detection records, every time one of your receivers notes the presence of an animal that you're tracking, that's a record.
That's a record.
And there's 625 million times you've tracked an animal.
Yes.
You've got a ping on your
Yes.
system. So how do you actually track a fish or aquatic animal?
Well, there's I always think of it as sort of three ways. There's the fixed receiver arrays, and this is where acoustic receivers are placed along the ocean floor or fixed to stationary buoys or something like that. And then anytime an animal passes by that receiver within a certain distance is then detected. That animal is tagged with an acoustic tag, and they can range in size from something that's big enough to be carried by a large shark to something smaller than my little thumbnail that can be in a small salmon smolt. And these receivers are usually across continental shelves, For instance, the Halifax line is the longest acoustic receiver line in the world, some 270 receivers. But then these animals have to pass by those receivers. And so that's what I consider OTN's sort of fixed platform. And then there's OTN's robotic tracking platform, which are autonomous vehicles, gliders, ROVs, but particularly gliders. And we operate both Slocum electric gliders and wave gliders. And these basically are pre-programmed to go wherever we want them to go in the ocean. And they carry a mini receiver. And so we can program them to go way off continental shelves and thereby tracking animals out that way. There's also satellite tracking. And there's any animal that's big enough to carry either a satellite tag affixed to their pelage or a pop-up tag can then carry a satellite tag. And this is important that they're animals that surface, because then when they surface, all the data about where they've been and what they've been doing is then basically directly uplinked to orbiting satellites. And so that becomes real-time information, and that's very powerful. And then the other sort of tracking platform is what we call biological tracking platform, or bioprobes. And that's where we have a unique type of acoustic tag called a VEMCO mobile transceiver. It acts as both a transmitter. So for instance, our pilot project for developing bioprobes were gray seals from Sable Island. And you affix this, you glue the transceiver to their pelage. And anytime that seal passes an acoustic array, it's recorded. But anytime that seal comes within receiving distance of another tagged animal, that's recorded. And then we developed a Bluetooth link where we put a satellite tag also on that gray seal. And when the animal surfaces, the Bluetooth connection transfers all the data from that transceiver to the satellite tag, up to the orbiting satellite, and then back to us in real time.
So is this one of those things, like so many things, that's getting faster, more complicated, or more capable perhaps, and lighter as the years go by?
Oh, incredibly. I mean, I think that's the one thing, is the technology is always changing and it's always getting better. We recently published a review article about the future of aquatic animal telemetry, and basically how as battery sizes get more powerful and smaller, basically we can make the tags smaller so that we can study more smaller either life stages or species. Certainly the kind of real-time information, which is becoming more and more critical, is also ever-changing. And of course, these autonomous vehicles are just wonderful.
Because it sounds like what you started with is a relatively simple, if an animal passes by, you know that it was there, and then you got more sophisticated and are able to tell more information about what it was doing before that, as long as it came to the surface. And now with Bluetooth, you can tell proximity. So can you imagine where this is going next? I understand batteries getting smaller and so on, but what might we be able to learn as this technology develops that we haven't been able to date?
Well, I think one of the big things that we think is really important is getting the data in more real time. Basically, the way that fisheries have been managed historically and currently are based on old data. We do trawl surveys or surveys of some kind, and it was maybe a year ago. It takes time to assimilate that data. We don't know the effects of some of the fishing activities, but if we can get these data in real time, then we can be more agile in the way we manage fisheries, knowing when populations are moving or when they're spawning, when we should protect them, when we should fish them, all should create a more sustainable use of the ocean. We work very closely with Fisheries and Oceans, or DFO, to help support their mandate and missions. I think one of the more exciting efforts we have worked with both DFO, World Wildlife Fund, is using our gliders to track North Atlantic right whales.
It's been in the news over the past few years. So can you start by telling me about the importance of right whales?
Well, the right whale basically was called the right whale back in the days of the whaling industry. And it was the targeted whale for harvesting due to a number of factors, unfortunately. But even after the end of that harvesting happened and they were essentially protected, they have continued to decline. And the North Atlantic right whale population is now one of the most critically endangered in the entire world. There's probably less than 400 individuals. So it is really critical that we do whatever we can to prevent that species from extinction.
And what do we know of the key risks to that population? There's 400 individuals. What's likely to be the biggest threats?
Well, we know really that the two biggest threats are shipping and fisheries entanglements. So basically, these animals are slow moving, they come to the surface, and they are struck by ships. Those collisions are probably one of the biggest sources of mortality. But also they get entangled in fishing gear, primarily gear for lobster and crab fishing. And then they simply can't swim or move, and that's the other major source of mortality. And because these animals, they basically migrate far south in the winters and then come back to Nova Scotia waters where they have plankton-rich waters to feed in. They are very susceptible when they are off our coast.
So we have both ships and we have fishing gear. So the value of tracking them is to understand the relationship between the presence of these key risk factors and the critically endangered marine mammal.
Right, to understand it, but to also, in this case, actively prevent it. Because if we know that an individual is there, we can notify the shipping industry that, please, you must go around this area, or you must slow to a certain speed, or if you're that big of a vessel, you have to be outside this area, or if you're setting fishing gear out, that you need to remove it during this period of time. That is maybe one of their key migration times, and then put it back when it's safe to fish again. And that helps everybody because it does not look good to the world if a right whale gets entangled in fishing gear. We have now seen right whales moving into the Gulf of St. Lawrence and have established, speeds that ships can go that will, help to prevent this kind of thing. And I think it's a really tremendous effort.
When you say in real time or very close to real time, what does that mean exactly? And you mentioned acoustic as well. So let's start with the first part. When you say real time, how soon after the whale is there do we actually know that it's there?
Well, the gliders, when they are at the surface, the data collected from the gliders is uploaded in real time to satellites. And then basically we have access to that data. The gliders are equipped with hydrophones that listen for whale calls, not just right whales, but other species as well. But because of the characteristics and nature of each of the species call, we can distinguish which species it is.
So we are listening for the whales, and on the basis of what those gliders hear through the equipment on board, it can determine what species of whale is there.
Precisely.
Wouldn't it be easier just to tag the whales? You mentioned something as large as a seal. I think you talked about gluing it onto a seal, and something as small as your thumbnail. So wouldn't it be simpler to attach something to the whale instead?
We very much wish that were the case. The problem is that seals have fur, and you can epoxy a tag to it, and basically that tag will stay on the seal until it molts the following year. So the animal is never going to carry that tag for its lifetime. You also, in certain cases, know you can get the tag itself back, for instance, when they return to Sable Island to breed. But with cetaceans, whales, dolphins, there's nothing to affix to the skin. And, people have tried things like little prong darts, but unfortunately they don't last very long, and there's concern for the animal.
What did we do before we were able to listen for them? How else did we even know where right whales might have been?
Those would have been primarily through aerial surveys, possibly shipboard surveys. And aerial surveys certainly are still underway, but there are times where the weather is inclement and that just doesn't work, and they're very costly. The brilliant thing about the gliders is there's no ship time cost, there's no carbon emission. Some of them are completely self-propelled, and so we can send the gliders out in inclement weather and in areas where we might not easily be able to get ships. So using the gliders is really quite effective. And then once the calls have been heard, then you could effectively use the aerial surveys without wasting a lot of time.
It seems as well that there's something about this that resonates with the public. People are interested in tracking the location of perhaps characteristic species, certain types of sharks or turtles. So is there a public engagement component to this, not just colleague to colleague in the scientific community, but working with the general public interested in this area?
Oh, yes, there's a huge interest in the public and engaging the public, even in citizen science. And I think that's always been a mission of OTN. And yeah, I think engaging people to understand that we tagged a great white shark off of South Africa, and within 4 months, it had gone over to Australia and back again. That tagged salmon smolts leaving rivers in Nova Scotia ended up in Greenland. It gives people a real sense of the fact that aquatic animals don't carry passports. They don't recognize national or international boundaries. And if we don't cooperate globally, we cannot manage sustainably the fisheries that we depend on.
You mentioned that you'd been working with DFO on the right whale and the interaction with fisheries, but how has that relationship gone internationally since this is a global network? How that relationship between tracking of animals and the work that the OTN network and its full spread does, and the management side, making decisions on economic activity, which is presumably very important to those communities.
Well, OTN has, for instance, partnered a lot with the Australians in trying to really track, for instance, white sharks and educate the public about them. And, with the eye towards mitigating harmful conflicts between humans and sharks, to not consider something like culling sharks, which are already endangered and are critical to the health of the ecosystem, but instead to basically better understand them and be able to inform and predict movements and habitat use so we can, keep activities separate and we can protect humans and sharks at the same time. We did a lot of work over the past few years with Arctic communities and the Inuit communities to examine existing fisheries management practices, which, for instance, in one case, the very highly valuable Greenland turbot or Greenland halibut, which is also known as a turbot, was managed as two separate populations. And then through our tracking studies, we found, and this was over a pretty broad area of the Arctic, and it turns out they were all moving back and forth, and it was really one population, and we were able to change the management boundaries. We did some work with, for instance, with the lemon sharks in southern Florida to really understand that some of the aggregations, the seasonal aggregations of these sharks, were not local. They were coming from probably 4 or 5 different states. That enabled us to better inform a management strategy. And, there are numerous examples like that.
So it sounds like there's no end of projects and issues to which the OTN network could be applied.
No end in sight.
And is this a matter of the ocean tracking catching up to terrestrial tracking? Is it that we're finally putting more attention onto ocean species where perhaps from the very early days of radio transmitter callers on land species, is this the ocean catching up finally?
I think so. I would say so because it's difficult to study animals in the ocean. It has been a lot easier to study terrestrial species, but I think both with animal handling techniques and development in that, we have come a long way. And then in terms of developing the kinds of technology that we need to track these animals has really changed a lot.
I can only imagine that the challenge of working in the marine environment is just that much more difficult, partly because you can't ever see it.
Right.
And it's salty and it's cold and it's dark. And so the technological challenges must be substantial.
Yes. And in fact, and it doesn't just stick with tracking ocean animals. You know, as we say, we know more about the moon than we do about the ocean. So working with aquatic species is just that much more difficult.
Sarah, thank you very much.
Well, thank you. It's been a pleasure to be here.
I've been speaking with Dr. Sarah Iverson, the Scientific Director of the Ocean Tracking Network.
To find out more about this podcast and the research featured in this episode, visit researchnovascotia.ca. My name's Rhys Waters, and we will see you next time.